Joe. There you are. Joe Firmage.
My battery is fully charged.
I think it's about 15, so we can move things along, right?
I'm sorry?
About 15.
20?
20.
All right.
20, though, the mic goes dead.
Okay. All right. Well, it's a pleasure to be able to address you today. I don't have any lightning special effects. I hope that Richard has not arranged a disco ball to fall down on my head. But I do hope to be able to share with you some mind-expanding concepts, as others have over the past couple of days. And I've titled my remarks today, 1491, question mark, if this thing will come up, because I do think that we stand at a cusp of perhaps even greater transformation than many of us have considered. It's a highly controversial point of view, but I hope to share with you a little bit of my reasoning today. I'm involved in a lot of activities both in the internet world and in the world of science. I'm going to concentrate today my remarks on the science half of my life, but I'll weave in the thread with a little bit of history of what's happened over the last 18 months that might illuminate the perspective that I'm coming from. Science is an absolutely wonderful way to spend your life. This diagram isn't to scale, but it's an interesting image because it does put into some kind of proportion in a single integrated view the disciplines that fascinate me. All the pixels on that screen are taken from actual photographs, from the Hubble Space Telescope to the Apollo mission shots of the Earth to shots of rainforest and, of course, a picture of a person superimposed. And, of course, if it were done to scale, recorded history would be probably, I don't know, a thousandth or a millionth of a pixel tall. But you sort of see the sweep of ideas that swim in the minds of scientists. And, of course, we're living some of the greatest revolutions as a result. The folks in this room have a predilection, of course, to creating things themselves with this knowledge. Information technology is a product, a fruit of the evolution of this wonderful cosmos that we are studying. Of course, there are still questions that are unanswered. Kevin Kelly's remarks I thought were quite interesting. What are humans for? What's our purpose? These questions have fascinated us forever. And we sort of tend oftentimes in our busy lives to shove them off and give them names like, well, that's an ontological question. We can't really figure that out. Some people, of course, call them spiritual questions, whatever you want to call them. They're really interesting questions to ask once in a while. So I'm going to ask a few of them today and take you on an intellectual journey that I've traversed. A few observations. Cosmologists and physicists have learned that we are made of the same kind of force that makes light. That's what we're made of at an elemental level. Really interesting to think about. We're close to a map of the human genome, and we are, of course, now designing forms of life routinely. We've invented a species mind, as I call it, the internet, enabling us to form new groups at will, an infinite domain to share and exchange our ideas and things. We are building our civilization upon an integrating network of controlled and controlling machines, from Palm Pilots to banks to web vans, ballistic missiles, space stations. One way to look at this is that we're building our own matrix. I call it an idiotechnomic organism, an ideology built into technology and economics as a system, a machine, a platform that supports modern living. Some of the questions that occurred to me as I was deeply involved in one of the early large companies of the internet economy is, what is the ideology of that machine? What is its programming? What have we created it to do? What is ours? And how has all of the above observations begun to shift our views? there's a wonderful philosopher by the name of Ken Wilber, one of the great philosophers in our time. He often asks the question, is there an integral vision for the trajectory of humanity in light of the types of things that are unfolding before us here? Never before seen transformations of humanity in every direction we look. Well, one way to attempt to look at it is to look at the trajectory of this idiotechnomic machine, the machine of modern civilization. And it's hard to track that except by the footprints that it leaves. One of the footprints was just briefly mentioned in the damage that we're leaving in our biosphere. The time scale is intentionally left off, except for the last two bars there on the right. It's about a 30-year time span from 1960 to 1990. About 20% of the forest deforestation occurred during that period of time. The rest is somewhat ambiguous, but the shape of that curve is pretty clear. And one of the things that was particularly troubling to me as an internet executive back in 1997 and 1998 was that a serious student of the internet economy can't help but observe that the scalability of consumption that is afforded by the increasingly frictionless economy is interesting when juxtaposed over some of the ecological trends that we face. So at the same time that human numbers are having the deleterious effects that they are on the planet's biosphere, we've just introduced this incredibly powerful machine that reduces friction from the processes of exchanging things. An interesting set of questions emerge. Are we, on present course and speed, building a matrix that is likely to rape Earth? Kind of a sobering question, but it is a question we need to ask, particularly since we're sort of at ground zero of the emergence of this machine. Another question. For what scale of civilization are we building this matrix? What is the long-term vision of the future that informs how we're designing it and how we architect it? If we can agree that there's some problem in this chart here, some problem represented by this chart here, how do we shift what consumers want to consume so that we change some of these trajectories? Perhaps the question that most interests me, how do we dramatically slash the dimensions of the footprint? Are there ways to actually impact that in a fundamental way? Well, this brings up a little bit of a history on my personal moral crisis, and I'll just share it with you so you have an understanding of what has unfolded over the past 2 years, give you some context. I think that the most powerful machine ever deployed, the internet economy, has begun spreading around the globe. And I was creating the largest services company in the world using it. When I left US Web back in 1998, we had, 3,000 employees in 10 countries, serving half the Fortune 100. And we began to launch new initiatives like intelligent e-services. We actually hired genetic programming experts out of various universities to begin to understand how you actually optimize electronic services for one-to-one marketing online, completely automated. All sorts of interesting new economies of scale. What began to really impact my psychology was that the ethics of modern society, at least from my lenses, didn't appear to be up to the challenge of dealing with this new machine wisely. And perhaps the most interesting set of ideas I'm going to share with you today is that I was aware of extraordinary issues afoot in the depths of science, which held profound promise for addressing some of the architectural deficiencies of our society, technologically and spiritually. Now, these are controversial, but I want to share some of these ideas with you today. What it produced in me was this crisis of confidence in my trajectory, the trajectory at least of my career. And I resigned from US Web CKS. We brought in a new management team, and I published this outrageously, arrogantly titled book, The Truth, that was actually a collection of essays from a number of folks, including me, weaving a storyline that at least points in a certain direction, different direction for the future than many of us had previously been seriously considering. So, in this context, I began to really study some new, emerging, interesting insights in science. And let me try to frame the relative scale of these types of questions that we've been studying. About 1,000 years ago, the turn of the last millennium, most human beings on the planet, almost all human beings on the planet, looked out from that little blue dot, didn't know it was a little blue dot, and all the lights in the skies were UFOs. These unidentified flying objects that moved in certain patterns. Some of them moved in slightly different patterns, and of course we came to call those planets. And through the brilliant physics insights of a few people such as Copernicus, Kepler, Galileo, we actually learned enough about the motions of these things to put a frame of reference in place at the sun and diagram how these bodies move. Well, that was a series of stunning insights that were incredibly difficult to make, that took centuries of painstaking observations to build a model to describe. Those are the types of questions that I believe are underway in physics today. And I'm going to describe a few of them for you. To generalize that previous diagram, make it a little bit more relevant to all of us, I put a simple chart up here that describes the sequence of our growing knowledge of core ideas in science, mainly in physics and chemistry, biology, the fundamentals of pure science, and then the implications for energy, propulsion, material sciences, and information sciences that flow from advances therein. From the energetics of molecules, we understand how to use petroleum to fuel our lives, to build automobiles and airplanes and work with alloys and build systems for transmitting information. Energetics of atoms told us how to do fission, with which we built bombs, and all the other things that we've done with that knowledge. Of course, the question is there a new domain of knowledge, a more fundamental, refined level of knowledge, on the left-hand block there, that would give rise to successors to the columns along the right? It's a fundamental question. If it sort of has ultimately a binary answer. Is there another big body of knowledge there that remains undiscovered, or isn't there? Or are we approaching the end of physics? Interesting and incredibly important question. Well, let me describe for you some of the, I think, startlingly simple questions that remain unanswered in physics today, despite all the wonders that we've done with technology, including this incredible machine with more computing horsepower than the world had in 1970, probably, sitting right here. We don't know some fundamental things. How do electrons move? Of course, we know that electrons move in an electric field. We don't know what an electric field is mechanically. We have equations to describe it, but there's not a clear mental picture, actually, of how electrons move. How does matter gravitate? Why is it that you're feeling the pressure on your butts right now in the seats? We can describe it mathematically, but there is not a coherent idea of actually why, the mechanism that causes atoms to come together. What are charge and light? The little charges that make up the atoms in your body and the light that flits around everywhere. Again, we can describe them mathematically, but we don't have a very coherent understanding of what they are. And force and energy, perhaps more fundamental than any of the above. We use these words all the time, casually. Even scientists, even physicists, perhaps most importantly, physicists use these words. Again, very well understood numerically, not very well understood mechanically today. So in the context of that previous chart, with these unanswered questions, interesting things, I think, are afoot in the core of science. Let me try to describe some of them for you. And I've engineered this not to go too deep, but I want to describe some basic ideas for you. Our two fundamental physics theories, quantum mechanics and general relativity, are widely recognized by the scientific establishment today to be in fundamental conflict with each other. Quantum mechanics describes sort of how atoms function, and general relativity describes sort of how atoms move across vast distances, but neither describes the domain of the other. One or both of them is, or both are substantially deficient as a result of this conflict. This is widely accepted but not widely publicized in the community of, among the community of intelligent folks. Both of these theories were founded within the notion that what we call space out there is nothingness, that it is genuinely empty, a true void where things travel through it, but it isn't anything in and of itself. Since 1980, experiments have proven that space is not nothingness. It is, in fact, a medium of intense energy. And the simplest way to think of it is sort of like slipping into bath water at 98.6 degrees. You don't feel the water, really. Another way to think about it is we're like fish who have been describing our physics theories of how we all move through emptiness. And then a few of us begin to leap out of the water and see, ooh, wait a minute here. We were in something. We were in something. It is, in fact, a medium of intense energy that we exist in. It surrounds us. 99.999% of the space in your body is space. And that's what it is, some medium of intense energy. There's a certain experiment that those of you who have some insane interest in physics can go follow it. It's called the Casimir experiment, and it describes the power of this medium of energy. And it's been clearly confirmed over the past several years. A few quotes for you to think about here. A physics wizard by the name of T.D. Lee. The experimental method to alter the properties of the vacuum may be called vacuum engineering. If indeed we are able to alter the properties of the vacuum, we may encounter some new phenomenon, totally unexpected. I'll skip over a few of these quotes. John Wheeler, one of the masters of physics in this century, gravity is an electromagnetic effect. Or in other words, gravity is a consequence or related to light. Very profound new views on the nature of these things. I'm going to skip through some of these, but hold on one. The possibility of reduced time interstellar travel, either by extraterrestrial civilizations at present or ourselves in the future, is not fundamentally constrained by physical principles. This is a physicist who used to work for the National Security Agency, runs his own institute down in Austin as a frequent consultant to NASA. A growing minority in the physics community, particularly the younger physicists, believe that we're in for some truly amazing surprises in the first couple of decades of the 21st century. One way to look at it is this. I call this a cone of comprehended reality. We have, on the one side, our knowledge of physics, which informs how we look at galaxies, stars, and planets. Of course, on our world, we have life forms, and we've created machines. Now, what happens when we gain new insights at the vertex of this cone is this. New cosmology observations and physics theories widen the cone and include new types of plausibilities that were once implausible. What would Galileo have said if a Motorola StarTAC fell out of the sky into his hand? He wouldn't have anybody to talk to, but maybe there was a voicemail. Anyway, the StarTAC surely would have been outside the cone of comprehended reality for Galileo. What is outside of the cone of comprehended reality for human beings at the turn of the millennium? What are the limits? What are the limits? So here's my hypothesis, that when we understand the function of atoms, not simply the energetics of atoms, a new layer of technology and ideas spring into view almost at once. It's almost in a binary switch. Our energy comes from the vacuum. We learn how to tap the ocean in which we exist. Our propulsion systems are electromagnetic. We engineer with atoms, and our information systems become totally mobile and immersive. And everybody sort of agrees with at least the latter, and perhaps this one too. These two are really, really interesting. But, you know, you can ask yourself a question. Why is it that the only really powerful thing we've ever figured out how to do with our knowledge of fission is blow things up? Well, I would submit to you it's primarily because we know how much energy is in an atom, but we don't know how the atom really functions yet. And when we do, we'll do the things that atoms do. Namely, create gravity. I believe that within the next 5 years perhaps, on the inside, on the outside 20 years, an astonishingly elegant, subtle electromagnetic circuit design capable of creating controlled unidirectional force within a volume of space will be created. It'll be conceived. We'll do what atoms do. Now, many physicists say, Joe, you know, you're just full of shit because the amount of energy required to create even the smallest amount of gravity is outrageous. It's outrageous. Well, that's only true if you don't know how atoms work, perhaps. Remember that we can design little electromagnetic circuits that produce magnetism, which is a force far stronger than gravity, yet produced by atoms with very low power. Now, many physicists say, well, magnetism is totally different. Other physicists say, no, it isn't. We just don't know how atoms work yet. So what would this mean? Well, energy from the vacuum with no waste. Limitless conversion of seawater to fresh water. Totally decentralized electrical power. Propulsion systems that boggle the mind. Silent, inertialess transportation for land, sea, air, and space vehicles. A society freed from the chains and costs of weight. And a species staring into the heavens in humility as the first starship launches. The first true starship. Almost finished. So, wow. I can't, many people say, I can't even think about that. I got enough to worry about with my new internet startup. Well, I have a lot of internet startups too, so I can't spend all my days working on these, but I spend a lot. And people say, well, is there any simpler way to understand this? Well, I want to take you back to the frame of reference that we left a moment ago. What many of the physicists that I'm talking about, all of whom I work with very closely now, most of whom I finance, believe that there is actually an evolution of this diagram. This very simple diagram that every one of us, of course, was taught in grade school about the view of the solar system. And it has to do with understanding the nature of space. When we remember that our sun and all the planets move around the galaxy, just as all the planets move around the sun, the planets actually follow spiraling helical paths of motion. A truer to scale version looks something like this. Isn't that a fascinating new way to look at the motions of the bodies of the solar system? This isn't perfectly to scale, but amongst the bodies it's to scale, amongst the bodies of the solar system. Helix within helix within helix within helix within helix. If there is in fact a medium of energy in space, this is a more accurate way of looking at the motions of the bodies of the solar system. Now, I didn't come up with this idea. This idea was in several textbooks that lost their way somewhere back 50 years ago, when the ether was finally banished from physics. I think it's coming back. And the possibilities it holds for all of us are so incredible, it's hard to even articulate them. I will close my presentation just mentioning two items that I'm involved in right now. The International Space Sciences Organization is preparing to launch later this year its commercial R&D enterprise, and our mission is outrageously audacious and very simple: to open the frontier of space. We have founders from NASA Ames and Lockheed Martin as our research team, and advisors on our board from NASA Breakthrough Propulsion, several physics institutes, and a couple of physics journals. This is outside of my Intend Change venture construction side. This is sort of the JFirmage thing that many venture capitalists haven't yet figured out how to tackle. But I'd like to join forces because I need the money and I need the help. I can't do this alone. And then another project that is being launched in collaboration with my venture construction company at Intend Change, and also a couple of other partners that we'll announce in the next 60 days. Pretty high-profile partners, actually. It's codenamed Project Voyager, and it will be a lifetime learning portal for science for all age groups. Science education is very close to my heart, and I hope to be able to contribute these ideas in a responsible way, as a scientist should, through to the public. So thank you very much for your time today. I appreciate it.
How old are you?